Hi, I am going to explain the image classification using CNN for dogs and cats. For dogs and cats, aim here I will classify two images, that is cats and dogs. That means it is a binary classification. In the training data set, I have taken 500 plus 500 data for cats and dogs. In the test dataset I have take 100 plus 100 dataset. Convolutional neural network. In deep learning, a convolutional neural network is a class of deep neural networks most commonly applied to analyzing visual imagery. They are also known as shift invariant or space invariant artificial neural network based on their shared weights, architecture, and translation invariance characteristics. CNNs are regularized version of CNN are regular version of multilayer perceptron. Multilayer perceptron usually mean fully connected networks. That is, each neuron in one layer is connected to all neurons in the next layer. The fully connectedness of these networks makes them prone to overfitting data. Typically, ways of regularization include adding some form of magnitude measurement of weights to be loss function. CNNs take a different approach towards regularization. They take advantage of the hierarchical pattern in data and assemble more complex patterns using similar and simpler pattern. Therefore, on the scale of connectedness and complexity, CNNs are on lower extreme. Here I take this is the overview of CNN's networks input features map, extraction map that comes from the after subsampling. The convolution or something, it changes the image size. At input. I have taken 32 into 32 pixels of the 32 into 32 pixels of the input size, and if I sample the images, I will, after convolution, I will get some layer, that is 28, 28 and 14 up, that is resampling and resampling the images, and it will become the more small and the increase the multiple number of layers. So and all the layers are fully connected. I am explaining details in later. Input layer, at first when we take the input data, we adding the 0 of the overall size for padding. This process is called padding, the putting the 0. These values 35, here the values 35, 19, that are the image values of the corresponding pixel value, and at the all side we adding 0, and this process is called 0 padding. Convolution layer. In convolution layer, the extracted image comes to a small size, and from the small size we will again extract more small size images and subsampling the images, and all the subsamples are fully connected. In convolution layer, suppose my input images is 6 cross 6 matrix, and this is my filter 3 cross 3. After convolution, that means it will compute this whole area with this matrix. We will get the first thing. Similarly, it will compute this 3 digit with this matrix and get this digit. Similarly, again compute this 3 bit with matrix, this digit, and at last this will 0. And similarly, from the next 3 digit and 3 cross 3 matrix will multiply with filter matrix, we get 0. That is the formula 10 into here. Simply we will get the outputs. See here, the full extraction of the all bits are collected from these patterns and getting the all values. Suppose my image size is n cross n and filtered is f cross f, and I have padding size p, that means extracting the 0, this is the 0 image size, that is padding size p, and straight says the final output of the image will be n plus 2p minus f divided by s plus 1 into n plus 2p minus f by s plus 1. pooling. Pooling means taking the value from a large email. We can take a fixed value for per decrease the complexity. From here, that is the example of max pooling. That means in this image we have 4 values 1 3 2 9. From these 4 values we collect the maximum value, that is 9. Similarly, from this area, these 4 pixels will collect the maximum value. This process is called max pooling. That means collecting the maximum value. Average pooling, in average pooling we will collect the average value of these 4 values, that is 3.75. so for this part, this is 1.25. Similarly, for 4 maximum values, this is 4 and this is 2. This process is average pooling. And now I am going to a real life example of CNN, that means classification, 2-dimensional. Here I take 2 input. One is cross, crosshair, and another one is 0. And now CNN will declare that it's 0 or 1. This image classification, at first how we will look at how computers see this image. Here this is X for us, but computer see this is a complete field background, and in the background all values are same. Here computer takes suppose -1, and that is 1 for the data value. In this position I have image data, and there is no data present for this image. After that, computer will resample the image in different pieces for collecting the same values. This process is done for checking there is same data bit present or not, because in this case the computer will small check, it can decrease the complexity of the images. After that, it will collect some pieces of features that is collected from this area. Suppose this here is 1 and 1, another one, here is another one, and here is 1 and 1, and this area is -1 and this area is -1. So this feature is collected from this 3x3 matrix. Similarly, from here it is collected here. In the same way, it is pieces the matrices and collect the features values. After that, this is my this is my filter matrix, and this is my total 9x9 input image. It will convolute these images with each pixels for 3x3 matrices and give the output as 7. Another for these 3x3 matrices with this value convoluted and give the value 1. Here my input give the 1. This is my total input images, and this is my filter image, so I get this is my output image convoluted value. The input images with the 3 different filters. As we get the filter from my previous images sampling, applying the all sample filter to this image and get this different values of images. After getting my input images with a convolution with the different values, this is 7x7 matrices, and we get 3 layers that for 3 different colors, red, green and blue. For 3 different colors we will get 7x7 into 3 deep matrix. So here I take the input value, convolution, ReLU, pooling, and get the output classified images. Yeah, I will explain later in the ReLU. Now I come to the so at last we will get input images, different layers, filters. After applying, we will get the output classified images. So how can we train our data? We have trained data set. That means here we have both cat and dogs. From this image we will extract the features, that means matrix values. In matrix value we have known, because we have trained this data set and we have already differentiate the input values from the classification part, that is label. We will put the label, that is cat or dogs, and after that we will generate our classification model algorithm plus parameters. In the test part we have unknown images. In this case we don't know the image. We will extract the images values as matrices. In classification part, we will apply our previously generated algorithms, and in here already we have put it the putted the values for cats and dogs as per our methods. In this method it will predict the output that the input images cats or dogs, and if it is cats or dogs then it will put the values of classification. Now we will go to the practical part. See how image classification is done. Yeah, as I say, there is two folders. First one is for train and second one is for validation but test. In train I have 500. See here, I have 500 cats and 500 dogs. In the validation part I have 100 cats and 100 dogs. Yeah, as for less time I am taking less image samples, but if you take the more images for training and test, the accuracy will be high. Now I have to make it as a zip file. Add to achieve zip. Okay, I create the zip file just because it will simplify to import the all packages. I will just copy the name and go to my code. Okay, in the practical part at first I import the packages. Import the packages TensorFlow, Matplotlib, TensorFlow, Matplotlib, NumPy, and other login and dataset. Now I load my data. As I have copied the file name, as I have copied my file name, that is cats and dogs small packs .zip. You see here, the output properties is .zip. I will paste the name here, .zip. Now run. Yeah, it is taking the output. So the cats and zips. Now I will declare the directory of base directory. Now you will assign the values for each and every purchase. Suppose base, I have base directory. The main folder is cats and dogs small pack, that is my base directory, and then my train directory. I have two folders, train and validation directory. Inside the train directory I have two folders, that is cats and dogs. So I declare this train cats directory, train dogs directory. Similar for validation cat directory and validation dog directory. Now count the length or number of files. In number of cats under train directory equals to length of train directory, number of dogs underscore train, that means length of train dogs, number of cats validation equals to length of validation cats, number of dogs validation equals to length of validation dogs, total 10 equals to total number of cats, total number of train cats plus total number of trained dogs, total validation equals total number of validated dogs plus total number of validation cats. Okay, I just run this code. Now print the total values that I have already calculated here. See, I have total 500 training cat, 500 trained dog, 100 validation cat, 100 validation dog. So total 1000 training images and 200 validation images. Now I will set the batch numbers. Suppose I have taken 10 and image save. I keep the image save 100 because my all imported image is 150 pixels. So I don't want to change it. Yeah, I can, if I want, I can take it 50. So for reshaping the images, or 200 for large the images. Now I will generate our training and validation dataset. In image generator, I will convert my image to a matrix. Here it is color image, so 1 pixel has defined by 8-bit value. So 8-bit means total 250, 0 to 255. I will rescale my images 1 by 255 for similarly both cases, validation and train images. So now I will train. Now you will generate train data. in train data image generator. Using image generator, I declare here the batch size. Already I have defined 10 table target and class mode binary. Here I have taken the class mode binary because I have only two types of image, cats or dogs. That's why I am taking here binary classification, similar for train dataset, also for same do as for validation dataset. Now I visualize my train dataset. Here is the coded for visualize simple training images. Now I will prepare a plot matrix here, taking one row and 5 column and giving the figure size and flatten the figure. That's all, nothing else. And total take the total images. Suppose I print 0 to 4 samples, so I take 0 to 5. That means here in Python 0 will initially 0 will be excluded and 5 will be included. So my image will print from 1 to 5. See the output images here, 1 to 5. Then 5 images printed. That means cats, dogs, cats, dogs, all are present here. If I want, I can see more images. Suppose I change it to 5 and figure size 40 to 20. So I can print total 10 images, 0 to 10. That means 1 to 10. Okay, now run this cell. So here my images will be 1 to 10. Okay, run. Total 10 image will show. It's taking some time. See, total 10 images. So cats, dogs. At first initially we have 5 images, and add another more 5 images. Now we will define our model. This is the main part in our coding. Here using with class TensorFlow models, that is convolution 2D model and activation function ReLU. I will define later the ReLU. I will defining after later. And input image shape 100 no change and 3 for 3 colors, and that is max blowing. I have already defined max blowing. That means we will take the maximum value of the significant from the matrix 2, 2. Here we make 2, 2 cross 2 matrix and taking the maximum value. That's for our max pooling. We run this code. Next we'll compile the model. Here we use the as a Adam optimizer. Taking the and create the accuracy, losses. Everything we will prepare in this model. And now you see the model summary. Here see total number of everything will be see the total number of piece, flat instance, everything. Total number is finally 12,90,946. Now we will train the model with the epoch. Suppose I take here anything as you want. I am taking 20 epochs, and I just run this cell because it will take more time. I am telling this is the epoch. Epoch in terms of artificial neural networks, an epoch refers to an cycle through the full training dataset. Usually training a neural network takes more than a few epochs. In other words, if we need a neural network, the training data for more than one epoch in different patterns. We hope for a better generalization when given a new unseen input. An epoch is often mixed up with an iteration. Iteration is the number of batches or steps through partitioned packets of the training data need to be complete one epoch. Historically, one motivation is that it gives the network to chance to see the previous data to readjust the model parameters so that the model is not biased towards the last few points during training. And during training here taking the history for model fit generator, train generator already we have defined. Step per equals to integer value of the total training divided by float value of batch size. So we see that step size will be definitely float, because integer divided by float will be output will be definitely float values. Here epoch equals to epochs already defined 20, and validation data similarly for validation step will be integer value of total value divided by float value of batch size. And now I left it for the next time. Here ReLU, I am saying that in neural network, the activation function is responsible for transforming the summed weighted input from the node in the activation of the node or output for the input. A node or unit that implements this activation function is referred to as a rectified linear unit, or ReLU in short. Often networks that use the rectifier function for the hidden layers are referred to as rectified networks. The rectified linear activation function is a piecewise linear function that will output the input directly if it is positive. Otherwise, that means it will output the input directly if it is possible. Otherwise, it will output 0. That means when it will negative, then output will be 0. It has become a default activation function for many types of neural networks because a model that uses it is easier to train and often achieves better performance. In order to use stochastic gradient descent with backpropagation of errors to train deep neural networks, an activation function is needed that looks and acts like a linear function, but is in fact a nonlinear function following complex relationship in the data to be learned. The function must also provide more sensitivity to activation some input and avoid easy saturation. Now come to the optimizer is Adam. Why I am choosing Adam? I am saying the Adam optimization algorithm is an extension of stochastic gradient descent that has recently seen broader adoption for deep learning application in computer vision and natural language processing. Adam is an optimization algorithm that can be used instead of classical static gradient descent procedure to update network weights iterative based on training data. Adam is different for classical static gradient descent. Static gradient descent maintained a single learning rate for all weighted updates, and the learning rates does not change during training. A learning rate is maintained for each network weighted and separately adapted as learning unfolds. Adam realized the benefits of both AdaGrade and RMS prop. Instead of adapting the parameters learning rates on the average of the first movements, that means the mean of the value as the RMS prop, Adam also makes use of the average of the second movements of the gradient, the uncertain variance. Especially this algorithm calculates an exponential moving average of the gradient int, the squared gradient, and the parameters beta 1 and beta 2 control the decay rates of these moving averages. The initial value of the moving averages and beta 1 and beta 2 values close to 1.0 result in a bias of movement estimation towards 0. This bias is overcome by first calculating the bias estimates before then calculating biased corrected estimates. Now go check here, our code is already 13 epoch is running. See here in the very first epoch, here we see the training loss, accuracy for 10 dataset, validation loss and validation accuracy. See here, training loss is very high, almost 69.9%. Training accuracy is 49.2%. Validation loss is 69.02%. That is very high. And validation accuracy is 56.4%. 5% is very less for the first epoch. Yeah, it will change because in the next epoch it will again the rearrange the weights of the neurons, then it will definitely increase the weight. See at the last it is still processing. Oh, yet during that time I am saying that here I will visualize the data. Here I will take two plots. Here I will put two plots. In the first plot we will put the accuracy history versus validation accuracy, and the second case we will put the training loss versus validation loss. So here that is the accuracy of train accuracy in x-axis, and y-axis is the validation accuracy. Here the in x-axis training loss and in the validation loss. Epoch we already given in the figure. Will set a figure size and upload because we will two images, that is 2,1,1 and 1,2,2, and here we will put the label, training accuracy, validation accuracy, and we'll put legend, title. If we want we can put the after run the code I will put the grade, save the images. So see my output is, just wait for few seconds, it will complete. Yeah, I have already told all of these things. Yeah, just wait, it will take 10 to 20 seconds just. Yeah, already 18 epoch is processing. After completing the all epochs we will visualize our result. Yeah, it will take more time, that's why I am taking the less epochs, otherwise it should takes more than 50 epochs, and also the number of trained dataset and test dataset should take more high. If we take it more than 5,000 10,000 data in for cats and dogs individuals, then our accuracy will be very high. As I have taken very low training dataset, just simple 1000 images, and test is 200 images, so our validation accuracy will be very less. See what's happened, it is coming almost 60 to 70% I think, because in 19 epochs it is coming the 64% accuracy for the test dataset, and validation is for, and training is for 67%. Yes, wait for the last set, wait for the last one. Yeah, see our output is total accuracy for test is 62%. It is very less as I told, because our number of data is very less. Now we will visualize our results. See here, that is our the graph. Yeah, graph is not so old, training accuracy is very less, and this is the valid test accuracy, and this is loss. Yeah, see the training loss will decrease after a certain time, this is the test lost. Yeah, we can plot the grid here. Suppose I give plot grid for this image, also for this image, plot dot grid. Now run. See the grid is on. Yeah, we can also save our images. As we select any names of the image. Suppose I put plot. See here, there is no images is present still now. After saving, I can save the output for different. Save fig within single quotation dot slash, give the file name. Suppose I give the result, sorry, re, I put the result dot png. Yeah, now run it. See the output will be, yeah, gap is coming, and there is a figure size here, that is so. And here my output has came results. Okay, so that is the total, and that is the total. So that is our graph, and thank you for watching these videos. I hope you understand. Okay, thank you.